Hi, good morning, and welcome to the ZP SenseItAll webinar. So we like to do this webinar once a month, and it's a sort of practical demonstration of some in vitro diagnostics technology stack from Zimmer and Peacock, and also a wearables technology stack from Zimmer and Peacock as well. I don't want you to think that this is just essentially a monologue from ZP. So I've got some hardware in front of me. I know that you'll be familiar with this kind of SenseItAll platform and the use of screen printed electrodes. For some people who will either watch live or watch the webinar later on, I'll also talk about microneedles and wearables, but the webinar is much more focused on SenseItAll today. If you've even seen previous videos, etc., of this, there is changes to this. That I've got a series of QR codes here that involve linear sweep voltammetry, square wave voltammetry, electrochemical impedance spectroscopy, amperometry, cyclovoltammetry, and open circuit potentiometry. And those are just to kind of demonstrate that SenseItAll is expanding its depth almost backwards. And when I say backwards, I mean into the kind of R&D stages of, we've always had SenseItAll as this kind of commercialization platform. And we demonstrate that SenseItAll is a commercialization platform because we actually use it in some of our product offerings. But we're also demonstrating now that actually it's always had the capability of being, I don't want to say a full-blown potentiostat, because that could mean lots of things, but at least an instrument for doing assay development upon. With that said, let me go forward. So today we're going to briefly touch upon microneedles. That's not the main thing, but some people who will either register or will watch the recording later on are interested in wearables. Commercialization strategy, TRL 3 to TRL 9. I really feel, sometimes we do talks with academia, and academia kind of stops at TRL 3, and then industry is meant to go from TRL 3 to eventually TRL 9. Now, TRL 9 may be a kind of post-market entry achievement, because I think you can it's very hard to have high volume manufacturing really before you actually have high volumes of customers. But we will talk about TRL 3 to TRL 9 and crossing the chasm. We'll do a demo of SenseItAll, but there's actually a philosophy in here as well. This is Zimmer and Peacock. I think we're fairly unique, that actually the technology that we display is actually really the practical demonstration of a genuine philosophy. And that philosophy, if I was a politician, I could call it the kind of 2-year manifesto. And I will talk about the 2-year manifesto, which is, if people are properly funded and they have the correct mindset, if I can put it that, we can get people CE marked in 2 years. Now, some assays are sometimes complex, but that complexity actually comes from constraints that have kind of come from the academic setting. And at ZP, actually, we try to make assays quite simple, and I will illustrate that today. So I will talk about IVD, in vitro diagnostics. I'm completely biased. This is a platform from Zimmer Peacock called SenseItAll, and then we also do have a wearables equivalent as well. If you've got a choice between doing wearables and IVD on your roadmap, definitely do IVD first. Wearables is a 10x harder problem to deal with. You can scan this QR code. So if you haven't scanned this QR code and you do use an Android phone, you can scan this QR code, and that will immediately give you a sense that what we're talking about today is already distributed, at least in software terms. So this is on the Google Play Store. You can scan this QR code off a Android phone, and it'll put the SenseItAll platform onto it. Don't think that when you go to market that SenseItAll will appear in anywhere, or even the ZP logo will appear anywhere. That's not the ZP business model. But this does give you a sense that what I'm going to show you today is not just ideas or vaporware. This is really, and to get an app on the Apple Store, if you've done it, congratulations. It's actually quite tough, because they do have why does Apple stuff generally work? Because they have a high quality standard. So ZP had to reach that quality standard in terms of the SenseItAll app in order to have it on the store. But what's nice about that is you can immediately kind of then be distributing your app also through the store as well, because you can write on the back of our, or on top of our app. Now, you will know that we've given this SenseItAll platform. So when I say the SenseItAll platform, I'll put my hand on it and sort of just so you know, it's a real thing, let's say. So this is the SenseItAll platform. It's got a sensor plugged in a bit. I'll be putting a fresh sensor in shortly. But we've been giving that application, in terms of we've been using it in the food industry for doing ingredients testing, including well, all over the globe. And applications like pH and nitrate and total antioxidative capacity and amperometric assays like glucose and potassium. When you peel back the applications we've been giving, there's voltammetry in here, there's open circuit potential in here, there's linear sweep voltammetry in here, there's amperometry in here as well. So we're in the end, we're giving application to fundamental electrochemical methods. What's new, and this is new today, I think this is the only second time in public that we talked about this, is that actually we're opening up the SenseItAll platform. Then again, I don't like the word potentiostat because it would actually suggest, oh, it's a potentiostat, but it's really a instrument to do lab work upon. So amperometry, open circuit potential, electrochemical impedance spectroscopy, linear sweep voltammetry, cyclic voltammetry, square wave voltammetry. So it's an instrument upon which you can do lab work. But of course, by just the use of a QR code, we can go from cyclic voltammetry to chili sensing, or from cyclic voltammetry to ginger sensing, or from open circuit potential to pH sensing, or from linear sweep voltammetry to nitrate detection, or from amperometry to glucose detection, or from open circuit potential to potassium changing. It's just the QR code. So suddenly, that transition from TRL3, which is, lab proof of principle, to that, let's say, application, which I would start putting as TRL 6 and 7. For us, it's just a QR code change these days. Like I say, I'm not going to make this the wearables webinar, but just to say that the technology stack also applies to wearables as well. At ZP, we mostly focused actually on microneedles. Just to say, some of you will know this, but this is our 10th anniversary this year. We are ISO 13485. I think we've been ISO 13485 since at least 2019. So for almost half that time now, we've been ISO 13485. We make standard products, and most of our income is actually doing contract development and then contract manufacturing for our clients, specifically in the biosensor world. As I say, we do a lot in wearables. This is kind of a model of the skin. The outermost layer of your skin is your epidermis. You've got your dermis underneath that, and then you've got your subcutaneous layer. So a lot of what we used historically done at ZP is CGM, continuous glucose monitoring. You'll see Abbott has the biggest kind of, at least, marketing budget in this space. So Abbott and Dexcom are big glucose monitoring companies, and they have that kind of wire element. ZP is kind of one of the leaders in microneedles. We've also done some work in non-invasive, and we've also done some work in implanted sensors as well. So just think of, I'm going to talk to this for about 3 to 4 minutes, and then we'll go back to IVD. So it won't be forever, let's say. But it does give a good indication actually of the technology stack that we do have, that this little device here is 50 millimeters across and 38 millimeters long. The entire electronic stack here is actually the little board that I'm hopefully hovering my mouse about at the moment. So what's the power of electrochemistry? It should be, it's fairly easy to miniaturize electrochemistry. The electronics are smaller than the batteries and they're smaller than the transducer. And we've been implanting this technology actually into fish. The fish here is not dead. It's anesthetized. And then the fish are basically sutured back up, which is a fancy way of just saying stitched. And the sensors are left in place. And then we're actually left with monitoring the glucose in those fish. So here we give the fish some food and the glucose jumps up accordingly after that. So we're lucky to have all this kind of IV. Well, at ZP, I mean, we do span this gap between IVD and wearables, and what we're quite good at is actually not reinventing the wheel every time. That if we make a formulation for an IVD, we're probably equally as good to make a formulation for a wearable sensor as well. More complex the assay, then the harder it is to make it into a wearable. So it's probably worth saying that we've got about 50 patents, 50 patent portfolio on wearable microneedles. And if people are interested, then I'll put some links down here. I'm going to talk now about commercialization, but I'm actually going to talk about commercialization for IVD work, because I do think wearables, actually, I'd actually advise people not to start their business journey on wearables. I think it's really hard. I actually think of any company that hasn't been well funded, I can't think of anyone who's been actually successful in that space. The only people that at the moment that are fairly well funded in startup worlds in wearables is BioLink in California, and they've raised so far in the last 3 or 4 years they've raised 150 million, but they were actually 7 years around even before they started these big raises. Um, it's very hard to think of anyone else who actually is as well funded as them. And I've seen some small startups in London, for example, but they're just not funded enough. But let's talk about commercialization. But I'm going to talk about commercialization in IVD. So subtext of all of this is when I'm talking about we can commercialize people in sort of 2 years or less. It is strictly speaking on the IVD platform. But the problem that we're trying to solve at Zimmer and Peacock is this kind of valley of death. Now, I know that some of you will have backgrounds from academia, and this kind of academia will bring people from TRL 1 maybe to TRL 3, but they kind of are disconcerted by the fact that their funding kind of runs out. But probably correctly so, because once you get into TRL towards TRL 9, then that's a commercial activity, and it should really be it shouldn't necessarily be publicly funded. It should actually be commercially funded. And so there's a gap then or not a gap. There's a industry kicks in, and we try to bring people to TRL 9, but then they kind of call this the chasm of death, which is, sorry, I should call it the valley of death actually, between where academia finishes and where industry can actually get to. Now, governments try to actually solve this problem by, funding research. And this valley of death, as a sort of title for this problem, and I think it's been around for more than 20 years. I put 20 years on here just to be kind of conservative on that figure, but I've been hearing about this for over 20 years. And the reason I'm still hearing about it is the problem's not solved. And so we actually have to intellectually think of the problem in a slightly different way. That at ZP, government just funding this is not necessarily working. In fact, it just leads to a lot of startups, and later on you'll see that failure rate is 90%. So at Zimmer and Peacock, we actually just want to close the gap, and I mean literally close the gap. So now I've already indicated that we've got this technology. In fact, the technology can go from doing open circuit potential to doing pH, for example, just by the change of a QR code. Now, the reason I bring that up is because it's literally closing the gap between what was a lab experiment and what was a commercial endeavor. And so rather than having this big gap where it says, well, I've used all my lab experiments and all my lab equipment, now I have to make new instruments and new, I want to say, things in order to be on the market. We say, no, just do away with that, actually. Now, we can be criticized for actually just saying, well, this will only work for simple assays. Yeah. I mean, that's partially true, but at the same time, I would always say if the assay is not simple, then it's never going to be low cost and easy to commercialize. And these kind of parameters that people say, I'm going to make a low cost scalable assay. It was like, well, if it ain't simple in the first place, then low cost is never going to come about. So we physically want to close that gap by actually using the same equipment that the academic would finish with, being the same equipment that the startup would start with. And so, here's, in fact, that was spontaneous, but here's a QR code for open circuit potential. If you put that app on your phone, Android, when I say that app, there were a couple of QR codes earlier on. You can watch the recording later on. If you scan those QR codes on your Android, you can put the app on your phone. And if you scan one of the QR codes using your iPhone, you can put it on your phone there. And then you can actually play with this because you can actually scan the open circuit potential. So now you've got something that is a lab instrument, and then you can scan this QR code, and suddenly you've got a pH assay now installed on your phone. Of course, those QR codes are no good unless you then got the instrument. But I'm just proving the point that you can go from essentially an open circuit potentiometry experiment, which is a lab one, to pH, which is more meaningful to most people. Because if you tell most people that that the most used electrochemical parameter in the world is probably open circuit potential, as well as amperometry, because amperometry is using glucose sensing, but they would look at you like you were strange. But if you actually tell them it's pH, then they're like, oh, okay, So if we look at the problem that we're trying to solve, this is particularly focused at startups. We got spend versus time. So in fact, the spend actually goes up. People think that somehow they're going to sort of spend is going to go down. I think spend always goes up, fortunately, and it's nothing. I think people think that once they've done the development, they'll cut the development off and then just start manufacturing. But once you start manufacturing, then you start having problems with scale up or things going wrong in production. So development never stops. It's just that the pie that development's eating into gets bigger and bigger because you're probably selling more and more. But most companies, I think most startups will tell their investors that we're going to get to market in 5 to 10 years. The reality is actually it's more like 10 to 15 years. And then when you look at startups, how many of startups are successful? Well, the failure rate is 90%. So the inverse of that is actually that it's the success rate is 10%. It may even be worse at the moment because I actually think that a lot of startups are really struggling to raise investment because the global interest rates mean that money's hard to borrow from banks. Therefore, the investment community is sort of sitting tight for a little bit. But we want to actually say you shouldn't be saying it's 5 to 10 years. And in fact, when it's in reality taking 10 to 15 years, we'd like to make this 2 years. But in order to do something in 2 years, you have to cut things away. So we say that by doing the hardware the way we are, we're cutting away some of these TRL levels. So technology readiness levels, obviously this is not obviously, but for some people you might not realize, but there's a NASA scale, TRL 1 to 9. When you're in R&D, you're doing basic, well, so if you're in academia, you're doing basic principles, technology concept, maybe proof of concept. And then when you're in industry, you're doing things like system prototype, system complete and qualified, system deployed. So how do you truncate or squash 10 to 15 years down to 2 years? Well, you have to cut things away. So we're arguing that through our hardware and our SenseItAll platform, we get rid of basic principles, technology concept, system prototype, that's definitely gone away. System complete and qualified. So this system is deployed and we are using it as a product. I mean, even this week, we've sold it to real customers to this week. Now, you might say, oh, that's not much, but that's to this week. And then system deployed. Part of the evidence for that system deployed is scan those QR codes. You will find that the software is deployed. So suddenly, some of these TRLs that you would otherwise be dealing with just went away. You are left with hard things. And the hard thing I think that you're left with is the actual assay itself. I think a lot of time and effort goes into parts that are actually not necessary, like electronics development, software deployment, and actually it's really the assay itself where the real value is. And I'll dig into that a little bit. So if you're going to say to people, oh, well, we can do things in 2 years rather than 15 years, then you've got to say, well, how? And this is the how, by having a technology platform where actually lots of the TRLs are just naturally ticked off, but it does leave you with work to do. And the work that I think is really left to do is actually around the assay itself. And I will try to sort of expand on that a little bit. So we have a technology stack. It's a hardware piece of hardware that I'll have in front of me and I'll do a demo. And then my colleague Guyana will also do a demo. We have sensors, so we have really reproducible screen printed electrodes. That's really important because I think so much time is just wasted going from vendor to vendor for different screen printed electrodes. And then maybe on a vendor, the sort of reproducibility from batch to batch is just also confounding people. I think I do a different webinar when I talking with academia, but the big problem I think in the world of screen printed electrodes, for example, is there's lots of vendors and each vendor possibly has 50 screen printed electrode configurations. So to just say that there was 10 vendors in the world for screen printed electrodes and each of them had 50 electrodes or 50 screen printed electrodes, that's 500 products on the market. So you've got quite a small market able to choose from a menu of 500 screen printed electrodes. That means that not one of those screen printed electrodes is made in high volume. And so what the screen printed electrode world is not saying to people is, because we're offering you so much range, in fact, our manufacturing volume for any one product is actually really low. And so therefore you don't really have a manufactured product, because a manufactured product should really be something that is manufactured daily and daily, but therefore bi-weekly. But actually what you find out is not bi-weekly, weekly. but within that, it's actually daily. But what you find out is actually they're making batches of electrodes. They're only selling a few hundred or a few thousand per year. So actually, the electrodes are sitting on the shelf for years. So lots of vendors offering loads of products, great. But actually, none of those products are really selling in high volume. So at Zimmer Pickup, we're actually we have to take a more just strategic and clear comment on this. This is what's happening. So at ZP, even though people say, oh, I need a really bespoke electrode, it's like, if you have a bespoke electrode, it will be low volume. Low volume means high cost and low quality. The only way you can have high quality is paying high cost for it. Oh, but I don't want to pay high cost because I want, that's why I'm choosing screen printed electrodes. Okay, if that's the case, then you're going to have to come onto a platform that we are manufacturing in high cost. So that's why we always steer people towards certain screen printed electrodes. So we have a technology stack. It has hardware, it has screen printed electrodes, for example. It has software. That software bit you can test for yourself. It also has a cloud system called Julie, and I'll show you that in real time as well. So let's say you're developing a sensor, and actually that technology is genuinely going to go to somebody who's remote from you. Maybe, remote from you is 50 miles, but realistically, I'm supporting people in India and Australia. And for my sins, I have never been to Australia. But actually, because they're using the platform, the data just automatically goes to the cloud. This is important because when you're supporting people, especially in remote regions or just distance from you, the fact that every time an assay is run, the data goes straight to a cloud and you can see the raw signal is really important and beneficial. So this exists, the screen printed electrode exists, the apps exist, the cloud system exists. So suddenly those TRLs or things that would otherwise you would need to make a product, tick, tick, tick. And we also have what's called an API built in, an application program interface. So that's also ticked as well. Now I put here add value because really, I think for most startups, and I would also sort of broaden this out to academia, the real value add is actually just in this central point here. That assay is where your real value add is. That's where your IP is. There's not really, electronics, people like to do electronics because they're trained in electronics, but it's really the assay where your real value actually is. The value, is in the central part here. So electronics are fun to do. I would say that electronics and engineering is very deterministic. If you have a plan to do it, you can do it. But science, you can have a plan to do it, and in fact, you end up not being able to do it. So science is really where your value is because that's the really hard bit today. It's not necessarily deterministic in science. You could put effort in and get no return on that investment. So I say that your primary value add is to work on the central part here. What does that mean? Coming up with the biochemistry that's actually going to work. Coming up with a method file. How are you actually going to make that biochemistry work? How are you going to excite that electrode? And then actually working on the calibration. So you've got the assay, you've got the method that's going to excite that assay, and then you have to turn that raw signal actually into a quantity, millimolar, parts per million, whatever those units actually are, viral load, whatever those units are. So those are kind of the three. If you're going to if you do a startup, what are the three main elements that you should be spending your time and effort on? We would say assay, method, and that calibration routine. And actually, when we do our demo today, we will have an assay, we'll have a method file running, and then we'll also do an automatic calibration. So the path today is at ZP, we obviously super biased. We got our electronics, I put this image up because I think something that's holding people back is this sort of poor quality of screen printed electrodes. This is particularly high quality, poor quality. And also I want to sort of say that we have somebody needed some screen printed electrodes the other day. And even then it was easy enough to just put a sticker over the logo in order to it sort of gives you a sense that at ZP we're not so brand orientated that we think our brand needs to go in front of the final customer. That's not our mindset. So in this case we just simply put a good adhesive sticker over the top of that to kind of change the branding on those screen printed electrodes. So we think that the path today is actually to focus in on the real value add, which is the assay itself. You've seen this already and I've talked about it, but if you've got an Android phone, you can show that this app is already deployed by scanning that QR code. You can show that the app is already deployed on the Apple Store by scanning that QR code. you can watch the recording later on, scan these different QR codes, and you will find that those method types will pop up on your app. And when you do that, then what you'll see is that you'll just get these different screens laying out, the open circuit, amperometry, linear sweep, cycle voltammetry, square wave voltammetry, and electrochemical impedance spectroscopy. It's kind of interesting, actually. I would almost describe Zimmer's and Peacock's path as almost in reverse. We started off by doing all the assays, and then we've kind of come back to working on them, sort of, opening up the method file. I think a lot of companies actually, they kind of start off with a potentiostat and then try to become a kind of commercial launch pad for other companies. And actually, we've definitely done it the other way around, because I think we're much more commercially orientated than a lot of people in this space. You can also play with your app and scan this code. This one will make your app run total antioxidative capacity. This one will make you run glucose. This one will make you run chili. This one will make you run ginger. This one will make you run potassium. This one will make you pH. And this one will make you run nitrate. The reason I bring that up is just to give you that sense of this is an instrument that's actually going between research and deployment really effortlessly. It's probably worth saying as well that if you scan this QR code, it will open up the idea that actually your assay, that's your assay. This will bring up a very generic page where we've left fields, and we're just saying that, everything that I'm trying to highlight can change in order that Zimmer Peacock does not need to be in your customer demos or in your investor demos, it's not our mindset to be there. We want to be successful, but we want to be successful as being, part of the technology stack. I can put the analogy this way. In the technology world, investors like the technology world. People say, oh, it's because software is easy to develop. But actually, when you really look at the technology world, it's because actually they're always riding on top of each other's technology stacks. So nobody runs server farms anymore. They go to Amazon and Google, and obviously Microsoft as well. But even people are now bringing AI into their technology offering. Well, we all know they're actually using, potentially ChatGPT. So the technology world, investors like it because actually those companies can go to market quite quickly. How do they actually do it? It's not just because it's code. It's because actually they're really integrating technologies underneath the hood of what they're actually doing. I would almost say there's a company out there called Salesforce, very successful. They've been running on Oracle databases for many years. They were effectively an application of an Oracle database. So what I'm saying here is that in the deep tech world, in biosensor world, actually people don't have that mindset. They just think, oh no, I need to rebuild everything. And I even find that governments and investors actually do expect them to build everything, because they don't have that understanding either, that actually when you build everything, it can take 15 years, and that the probability of success is actually only 10%. I think we need a more technology world thought on this. But actually, why are they quick? Well, yeah, it is software. It is quick to code and iterate, but it's because they're actually riding on top of a whole technology stack from other companies. And so I think we should be doing this in deep tech as well. Now, the reason I show this particular video is because one thing that we are pretty good at Zimmer Peacock is keeping things simple. So even if people say that my assay is an immunoassay and it's complex and it can't be simplified, well, we do face that kind of comment quite a bit. So this was a demo that we did the other day. It's on YouTube, but actually in this particular one, I didn't rehearse this with these guys. These guys just ran one of our assays on our instrument, just almost intuitively, actually, without any kind of prompting from the parent in the room on this particular one. Now, so this is a representation that actually, we have this app. It reads QR codes. By reading QR codes, it then tells the meter what to do. And then but for every QR code and therefore every method, there has to be a sensor that's been made specific to that particular assay. So we have pH, nitrate. You can do this demo yourself. TAS, glucose, potassium, capsaicin, and gingerol, and then yours. That's an important one. That's that kind of whole mindset that all I'm trying to talk about, whoopsie-daisy, what I'm really talking about today is actually demonstrating that we're really just trying to get people to actually do their own assay and have their own kind of company success, let's say. Now, that app will talk to our cloud, and I will show that shortly. So you'll get a result there and then on your phone, for example. But actually, the raw data is also saved to the cloud, and you can share from the cloud. You don't have to email files and stuff like that. The cloud is basically a sort of a folder system that has folders and files in it. So every time an assay is run somewhere, the data automatically goes to the cloud. And we'll talk about that today as well. So I'm going to do a sensor to cloud demonstration. So what I'll do is I'm going to just stop sharing my screen for a second. I'm then going to go to here. So I'll put my hand on the device. So I've got the app running on my phone. It says here on my app, it says device connected. So that's actually a Bluetooth connection with one another. I'm just going to take off the sensor. I'll just snap out a new sensor and I'll put the sensor. Now the usability is really taken care of here, that, there's no slots here. I think that slot idea that we're going to slot things in, well, I don't think, I know it comes from the glucose world, and it does make for a low cost technology, but it also means that you've run dangerous things like ingression. And I would also suggest ease of use is not actually that great with slots. Slots were something that was really invented when I say slotting sensors was something that was invented approximately, I would say, mid 80s to early 90s, and actually people are still using that design consideration. But I think the world is actually, the cost of manufacturing has gone down. We can make much more elegant, and that's how I make the electrical connection. I just click it up like that. I'm just going to put the sample on there. So that's one of the beauties of, let's say, electrochemistry, that actually we never need that much sample. I'll go to assay. Let me just go back. I just want to check what name I've put on this. So I'll just give it a name. And then I'm just going to go to assay. Just tell it about my dilution that I used, and I just go start measurement. So the device now, talk about usability, because of the angle of that camera, you can't see it, but you may be able to notice that the end of my finger is flashing because there's an LED that's actually running here. So that's telling me, the little white LED here tells me the machine's on. There's actually a nice row of, it's a strip, which flashing away and telling me that the actual machine is running. And that is part of that kind of, how do I put it, user experience that actually, we're trying to kind of, guide people that, that things are essentially working. So what I'm going to do now is this LED has now gone green. So I'm told that the assay's finished. I get a result on my phone. I might just change to a different camera and hold it up. This is a 100% demonstration of the robustness of this technology, that we are going live at this moment. In order to do live demonstrations, if any of you have ever done product development, you know that you're sweating when you're doing live demonstrations because actually you're worried that things are not really going to work. But we have to have confidence in this technology stack because we are able to do live demonstrations. And in fact, what happened was I got a result on my phone, and in parallel with that, I'm just going to share my screen now. I'm just going to click to here. I can see my sample is here. And when I say sample, see my raw signal went up here. So we never showed in that demonstration, the fact was that it was actually doing voltammetry. But I've got the voltammetry, I got the result. So that's that whole part about calibration. So I got the calibrated result. This is how we did the analysis. We actually opened up a window in the data and told it to sort of find the peak. It got the peak height. It went from peak height to a bit convoluted micromolar to Scoville heat unit in this particular case. This wasn't something I was planning to do, but actually, because we can essentially, this was running cyclic voltammetry. So in fact, we did a first cyclic voltammogram and then a second cyclic voltammogram, a first cycle, second cycle. And actually, we did all sorts of processing on that data in the cloud. So things that you think you're going to code, like data smoothing, integration under curve, application of calibration factors, things that you think you can code, you're going to code, actually you're just going to end up entering them into fields up here. And so suddenly think about, this is much more, let's say, doable by the scientists here in the lab. And in fact, some of those skill sets that you thought you would otherwise need, like, coders, etc., just became a lot easier. So what I will do is I'm going to stop sharing for a second because I want to demonstrate that it's not just me. What I'll do is I'm going to mute myself for a second, and turn off my camera. My colleague Anna is going to do a pretty similar demo, but we just want to kind of demonstrate that, it's not just a one-trick pony. So let me just do a sound check. Anna, are you there?
Hi, yeah, I'm here. Hi everyone, I'm Gaina. I'm an engineer here in Zimmer & Peacock, and I'll just demonstrate our SenseItAll platform. I'll change my screen to show what I have with me. I have the SenseItAll device. I have a QR code, which is for ginger assay. Particularly, I have some solutions to test, and I have ginger solutions. Also, I will need a mobile phone to run the application. So we can go ahead and start. So the first thing I will do, I will connect the device. For that, I will need to press the button that is on top of the device for 2 seconds. And then I will see white LED glowing here, and I will also see blue LEDs here gliding, which means the device is ready to be connected through Bluetooth to the mobile app. So from the mobile app side, I will press the connect the device icon. And now the app search for available devices and found SIA 2037. So if I click on it, now it will try to make a connection. And now I see it's connected, and I see the device serial number, and I see the device picture on the top of the screen. What we can do next, we can scan the QR code. I'll press the QR icon, and new screen will appear, and I will just simply hold on top of the QR code. And now I see that app is set it up for ginger sensor assay. We can change some test settings. So this card, this is on the bottom of the screen, is tappable. So I can tap on it and then set up some sample ID and cluster name. So sample ID, I will name it as a ginger, maybe test 1. And cluster name, I will name it demo. So the cluster, you can think of it as a folder. So these 2 inputs are making easier to find the data in Julie once the measurement is done. So I think I'm done here. I'll just press go back button, and I'll go to assay to see what I need to do. So I had some ginger shot and I mixed it with a ginger buffer with 1:10 ratio, and I made the solution to test. So in select dilution factor from the app, I need to select 10, which is already done, so I don't need to change anything. The next that apps tells us to do is to place and lock the cartridge. So I will place it here and then click this part up, and the device has spring-loaded connectors, and which are connecting to the sensors connector pads. Once this middle part is clicked up. Yep, I did this too. Now we need to apply 50 microliter of sample. I will take it with the pipette. And cover all the electrodes. And this is done. I can press start measurement button to initiate the measurement. So this assay takes about 30 seconds. What we do with that, we run cyclic voltammetry, voltammogram, and we send the data from the device to the mobile app. And the mobile app sends the device to the Julie, which is our cloud platform, where the data is stored, also it's analyzed. And once the algorithm is running, and once it's done, it sends the results back to the mobile phone. And now we see that results are back, and we get results with molarity and also milligram per liter. I will remove the sensor now. And I see on the app that it says the plot was complete. And I also can verify that LED is green here. And I can press done button. And I see that it's white. And I can run the next measurement if I want. But now I'll just change my screen and show you what results I got in Julie. So this is my demo cluster, which I already initiated from the, which I stated in the mobile app in the beginning of the measurement. So I will need to refresh it. And I see SIA 2037, which is the serial number of my device. So I'm clicking on it and I see Ginger Test 1. This is the sample ID that I stated in the mobile app as well. So I will click on it. Now I see the raw data. I see the first scan and I see the second scan, and I also see pre-processed data. I can also see peak height and molarity values, which are algorithm detected. I think that was all that I prepared, Martin.
Yeah, perfect. Well, I appreciate that, Guyana. So thanks for coming this morning. So I just want to kind of summarize up now. So if you're going to turn your screen off, that's great. So just to kind of summarize, we did talk about microneedles, but really only in passing. I think the most of what we've talked about today is IVD. If you're interested in microneedles or wearables, just reach out to us at Zimmer Peacock. You can see that what we're demonstrating here is generally a platform that you can actually install even today on your obviously on your phone. You can scan those QR codes by watching this recording later on. And genuinely, I would actually completely argue that that gap between lab experiments and actual deployable technology is physically closer. So rather than that kind of government strategy or that, of let's throw money at technology so hopefully we can get from across this chasm or this valley, we literally have engineered the gap to be actually shorter. And Zimmer Peacock's business model is quite simple. It's contract development, contract manufacturing, and one way of getting people actually onto the market quicker is to get them onto this pre-configured platform. So you saw a couple of demonstrations today from a couple of us. I like having two of us because we both have a sort of slightly different perspective on things. So Guyana actually did a much better job than me of tilting and showing you that, that user experience. And just little features as well about how we actually made that electrical connection. I think you can understand that I said it myself that slots is awful on instruments. The reason we used to do slots, by the way, and what used to happen is, a little bit of liquid would just touch a slot. A slot's like a capillary. Solution would just suck straight into it. So it was absolutely awful. So if you've got any further questions on Zimmer and Peacock, don't hesitate to reach out to us. We do appreciate you coming this morning, and I do obviously recognize who's here. But of course, any questions, don't hesitate to reach out to us, and I will send you a recording of this shortly. So I just want to say thanks, Guyana. I know that you and I have a meeting shortly, so I'll wrap up. And as I say, a recording will come out. Okay, take care and have a good rest of the day. Okay, thank you very much.